of the given magnitude and directional angle component form is in the form A, comma, B, where A equals R times cosine of theta. In this case, it'd be 5.3 times cosine of 321 degrees. And that's going to be about 4.1. Well, they'll have 4.1 in it somewhere. All right, so let's get our B value. B equals R times sine of theta. In this case, our R is 5.3. Sine of 321 degrees, which is about negative 3.3. Our A comes first, so it's 4.1. And our B comes second, so it's negative 3.3. Oh. Make sure if you're in component form, that does not mean make everything positive. All right? The only time you make it positive is if I ask for the magnitude of the components. Magnitude of the components means takes the absolute value of both of them. This one just says, just find the component form. Component form can have negatives. Magnitude of the components cannot have negatives. Did that answer your question? Okay. So your goal when you're reading this, if it ever says find the magnitude, whatever it says after that, you're taking the absolute value of whatever you're finding. So if it says find the magnitude, ... that means that's where you put the absolute value in it. It doesn't say that. It just says find the component form. All right, don't get those wrong on the test. That's an easy 2 points to lose. All right, questions from the homework. Ross. 63. 63 was R squared equals 9 times cosine of 2 theta. Well, the problem is we do not have an R squared. We just have an R equals.
I didn't see the squared.
Oh, okay.
Is it just 3 times square root of cosine 2 theta?
Well, I'll just put everything underneath the square root, so I'll just do it up here. Because this is one that some of your calculators are going to struggle to actually graph. So if I have y equals, and we'll just do the square root, it actually is the plus or minus, but it really doesn't affect this answer. If I just do the regular square root of 9 times cosine 2 theta, and I graph that, if it lets me graph it, it's going to look like there's missing parts. Those gaps don't actually exist on the graph. So you'd have to do is go to your window and change your step count. Maybe I'll make it 0.03. And I'll graph that. It's going to take a lot longer, but you can see it actually filled in all those missing sections. And that's exactly what it looks like. Are there other questions from the homework? Yeah.
Okay, so I got it right, but I want to make sure like what I did was technically how you're supposed to do it. For number 73, so it's theta equals 30 degrees, so I just like graph 30 degrees and 180 equals 30 degrees to get like the other side of it. Is that technically right? Or
Well, you just have to do the straight line. You don't have to worry about the... So you don't have to worry about even going the 180 or anything. It just says this straight line. So theta equals 30 degrees is that straight line both directions. And the way you kind of think about that is if I ever ask you to graph x equals 2. You can't plot that on your calculator, but what you do is on your xy plane, you count out 2 units, and then you just put a straight line through number 2, up and down. The same logic applies there. It's not something you can graph on your calculator. You just have to know 30 degrees is going to be that whole line. That's 30 degrees. Okay?
Thank you.
Yep. Other questions from the homework? All right, then on Friday, Friday we converted polar coordinates to rectangular coordinates. And we converted rectangular coordinates to polar coordinates. Today what we're going to do is we're going to convert polar equations to rectangular form or rectangular equations. So, in a polar equation, you are given things that have r and theta. When you plot it, you go to your r equals thing. Well, I want something I can plot as y equals x, y equals 2x, y equals 3x. So I need to change all these r's and thetas to x's and y values. The way we're going to do that is just using our knowledge of x's and y's and thetas and r's. Primarily, we're just going to write a bunch of facts right above this that deal with x's and y's and r's in the given spaces. So we're going to write something like, remember that cosine theta equals x over r. Another way to think about that is you can go x equals r times cosine of theta. We can do the same thing with sine. Sine of theta equals y over r, which we can rewrite as y equals r times sine of theta. And the last thing we have that deals with r's and x's and y's is the fact that r squared equals x squared plus y squared, or r equals the square root of x squared plus y squared. So our goal is to cherry pick one of those 6 things to help us solve this equation. There really isn't a wrong way to do it, but there are easier ways and harder ways to do it. What I like to do a lot is if I have cosine theta, right? Well, we can either use this fact or this fact. To use this fact, I have to multiply both sides by r. All right, because x equals r times cosine theta. So maybe we'll choose that method. Multiply both sides by r so that I have r cosine theta. So I'm going to multiply both sides by r, which you're allowed to do. It keeps it all balanced. And that's going to give me r squared equals 2r cosine theta. Well, now I have this r cosine theta. Well, r cosine theta just equals x. I'm also going to notice that we have an r squared. R squared equals x squared plus y squared. So we're going to replace that given information. So instead of r squared, I want to have x squared plus y squared. That's going to equal that 2 times, we're going to replace that r cosine theta with just x. I'm not overly concerned about you guys simplifying these equations. That will be fine for your answer, because we have simplified x and y's over and over again. I'm not worried about that. We're just going to leave it as that. I want to make sure you can turn your r's to x's and y's. I want to make sure your thetas become x's or y's as well. All right, our next one is r equals 19 over sine theta. There's 2 kind of methods we could use. We could take this sine theta and say it's y over r. But then we have 19 over y over r, and then several of you struggle with fractions, and you might actually struggle solving this. So what I'd probably do is I'd simplify your fractions first, and then worry about reducing them down. To simplify that fraction, I would just multiply both sides by sine of theta. Multiply both sides by sine theta. And that's going to give me r times sine theta equals our sine theta, and our sine theta will turn to 1. It'll just equal 19. Well, r sine of theta just equals y, so we're just going to have y equals 19. So going from polar to rectangular is really locating your r's and your thetas and using these general rules to get rid of them and turn them into x's and y's. All right, going the opposite direction is the exact same thing. So the next thing is we're going to convert from rectangular to polar. I give you x's and y's, and you have to shoot back out r's and thetas. So we're going to use all of those same facts that we used from above. I'm not sure if I had to list them all. I don't think you have to use them all. I usually don't. Yeah. So we're just going to list things like the fact that x equals r times cosine theta, y equals r times sine theta. And then we'll also go with the r squared equals x squared plus y squared. All right, first one says y equals 3x minus 2. Well, going this direction is a lot easier a lot of times, just because you just replace your y's and x's, which what is given to you. So y equals r times sine theta. So we're going to replace that y with r times sine theta. And that's going to equal 3 times, replace this x with r times cosine theta minus 2. Since we haven't done this much, I would like us to solve for r. Because when we're doing polar coordinates, just like with rectangle, we usually have y equals, we usually have r equals on these. So we're going to actually solve for r in this case. So that means I'm going to get all the r's on one side and see what I can do from there. So if I subtract 3r cosine from both sides, we're going to have r times sine theta minus 3r cosine theta minus 2. I forgot an equal sign. How about equals? Yeah, that makes a lot more sense. Equals a negative 2. Well, just like when I'm solving for x's or y's, what we're going to do is we're going to factor out this r in front of both of these to give us r times the quantity sine theta minus 3 cosine theta equals negative 2. And then I'm just going to divide whatever is multiplied by the r. So I'm going to divide both sides by sine theta minus 3 cosine theta to give us a final answer of r equals negative 2 all over sine theta minus 3 cosine theta. All right, our next one is either really complicated or really easy. So you could replace your x with r cosine theta, square it, and then have your y to r sine theta, square that, simplify stuff, solve for r. Or you can simply recognize that r squared equals x squared plus y squared. So we can replace this entire x squared plus y squared with r squared equals 9. Take the square root of both sides, and you'll have r equals plus or minus 3. So look out for x squareds and y squareds when you're going that direction. All right, that's it. That's the whole lesson. The rest is just homework. I also gave you your review because the homework isn't super long, so now's a good chance to get started on the review. Tomorrow I'll take a poll at who wants to take the test on Thursday, and then I'll procure if there's like a teacher or something that has their room available that you can go into. Because if it's anything more than 2, I can't just stick you in the library because there's too many people taking the test. All right, rest of the time is yours to work and ask questions.